Okay, this is question 8, and in this case we've got a vertical cliff 73.5 meters high, and we're going to project two stones. Stone A is projected horizontally from the top of the cliff with a speed of 28 meters per second, and stone B is projected from the bottom of the cliff with a speed of 35 at some angle alpha above the horizontal. Okay, the stones collide, and we've got to find the angle of we're going to show rather that cos alpha is 4/5, and then find the time that elapses when the stones collide. So imagining this thing diagrammatically, we've got something looking like this. So that here's our cliff, say down here. We fire stone A off, so it's got an initial velocity A of 28 meters per second to the -1, and here's stone B. It's gone along up here, initial velocity 35 meters per second to the -1. And the two things intersect at this point over here. And we'll say that this displacement here, the distance from the cliff where they intersect, is some distance x. Okay, so we're going to find alpha first of all. So we know that when they intersect, that this distance is going to be the same, and we know that the time is going to be the same as well. So we'll consider things in the horizontal displacement, in the horizontal direction first. So in the horizontal direction, what we've got is, for stone A, we've got the time is the displacement x divided by the speed 28. And for stone B, we're going to take this velocity here and we're going to split it into its vertical component, which is 35 sine alpha, and its horizontal component, which is 35 cosine of alpha. So at B, the time is going to be the same, and the displacement is also going to be the same. So time is displacement divided by the speed, which is 35 cosine alpha. So the point of intersection, these two times must be the same. So we can say at the point of intersection, or the point of impact, then x over 28 equals x over 35 cosine of alpha. So the x's cancel, so we've now got 35 cosine alpha equals 28. Divide through by 35, and then simplify, and we've got our answer, which is 4 divided by 5. Okay, so if we know this is 4/5, we can find sine alpha, so we can get the vertical component as well. So it's just simple 3, 4, 5 triangle. So there's my alpha. Cosine alpha is 4 divided by 5, the adjacent divided by the hypotenuse. So 4 divided by 5, so that's a 3. So sine alpha is the opposite divided by the hypotenuse, 3 divided by 5. So we can back up to the diagram. 35 times 3/5 gives me 21. Okay, now we're trying to find the time. The second part of the question was to get the time when these two stones intersect. This point here. So, so what we also know in the vertical direction is that the two heights must be the same. So what we'll do is we'll look at the height and the trajectory for stone B and for stone A. So we're going to look now separately at the vertical components. So for stone A, the initial vertical velocity is equal to 0. The vertical velocity at the point of intersection we don't know. The acceleration due to gravity, A, is minus 9.8. The displacement for A, we're going to make the displacement for A, we're going to reference that displacement for A from this datum here. So this is the datum for A. So we just call S basically equal to SA. And the time is, again we don't know, we'll just call that T. In fact, that's what we're trying to find. UVAST. Okay, so if we want to get an expression for the displacement of A, well, which set of equations of motion sort that one out for us? Well, it's S equals ut plus a half at squared. And in this case, u is equal to 0, a is equal to minus 9.8. So the displacement S, basically this is SA, is equal to half times 9.8, which is 4.9, and it's a minus, so I get minus 4.9 times t squared. Obviously t is what we're trying to find. Now again, do the same for stone B. UB is equal to the 21 that we worked out before. The velocity of B at the point of impact, we don't know. The acceleration of B is the same as the acceleration for A, it's minus 9.8. The displacement, we'll call that SB, which is what we're trying to find. And the T also is what we're trying to find, which is T. Okay, so again, what ties all these together? The thing that ties these together is the same equation that we used over here. So we can say that the displacement for B is ut plus a half at squared, and u is 21, so we've got 21t plus a half at squared. Again, a is 9.8 and it's minus, so this becomes minus t squared, or minus 4.9 t squared. Okay, so and what we're basically doing here in terms of this displacement for B, we're measuring that displacement from some datum over here, datum for B, which is this one along here. Now we know at the point of intersection that the that the heights must be the same. You know, the height of B above the ground must be the same as the height of A above the ground. So the height of A above the ground is going to be the 73.5 minus this value that we've got down here. So at the point of intersection, or at the point of impact, then the displacement for B, the 21t minus 4.9 t squared, must equal the height that we threw A off at 73.5, the height of the cliff, minus this absolute value down here, minus 4.9 t squared. So these two things here are going to cancel, so that means t equals 73.5 divided by 21, and that gives me 3.5 seconds.